One-step equations. These are examples of equations. The goal when you're asked to solve an equation is to find out what the unknown pronumeral is. So this is saying something plus 3 equals 7. Now it's pretty obvious, it's 4. Most of you can already work that out. The problem is we need to work it out with the right method so that when we get to more complicated equations, we have the right tools to do this. So I'm going to focus on getting the working correct. Now what this is saying is, I don't know how many lollies are currently held in Ms. McClintock's hand, but when I add in 3, I can tell you that I've got 7. So I can say, look, that's 7. But that's my unknown. I could even draw an X on my hand if that would help. X plus those 3 is 7. The question is, what's that? Obviously, knowing that this is 7, to work out what I had in my hand to start with, I've got to take away those 3, and oh hey, I had 4. Another way of thinking about it is saying, I started with X, I added 3, and I got 7. So to find out what I started with, I've got to reverse what was done to X. So here, what was done to X is 3 was added to X, and I got 7. I'm going to have to take away that 3 from the 7 to find out what X was. And another way of thinking about it is that the two equation sides have to balance. So on one side, I've got X plus 3. On this side, there's my X in my hand still, plus 3. That equals, I'm going to get rid of this paper for just a minute. So, we'll make it a different equation so you don't know the answer. X plus this one that I have here, X plus 1, is equal to 3. X plus 1 equals these 3. The mystery that has to be solved is what's in here. I can find out if I've just got X on its own over there. If I take away 1, that's no longer equal. But if I take away 1 from both sides, it stays equal, and it's very clear that X equals 2. So this is 3 different ways of thinking about how we solve equations. But what we come down to over and over again is we ask ourselves, what was done to the pronumeral? Three was added and we got 7. And so to find it, we've got to get the pronumeral on its own by doing the reverse, the opposite, to both sides. So, 3 was added, so to get X on its own, I'm going to take away 3 from this side and take away 3 from this side. X plus 3 minus 3 cancels out. Now I'm going to write minus 3 in a little circle here because you're probably taught to do minus 3 to both sides, but this isn't really great working. But it's just a reminder of what's happening. X plus 3 minus 3, that cancels out and leaves me with X equals, and now I've got to do 7 minus 3. and 7 minus 3, x equals 4. I do the opposite of what happened to x to both sides to get x on its own to find out what it is. I had x, I took away 4 and I got 6. So what minus 4 is 6? It's going to be 10. But to do our working accurately, what was done to x? 4 was taken away from it. I've got to do the opposite of taking away 4 to both sides. X equals 6 plus 4. So the opposite of minus 4, or taking away 4, is adding 4. Adding 4 to this side says I've just got x. Adding 4 to this side, 6 plus 4, x equals 10. Notice that what it looks like I'm doing is taking the minus 4 and putting it behind the number that's here. Oops, sorry about the light there. Taking the minus 4, putting it behind this number and changing it to a plus. So you will always write whatever was here and then do the opposite after it. So, when x plus something, we minus that. When I've got x minus something, we add it to both sides. So we're doing the opposite of what was done to the unknown letter on both sides. Now this one might be a bit tricky because I've got 2y equals 10. This means that y was multiplied by 2. So to get rid of a times by 2, I divide by 2 on both sides. Now, what that does is if I do 2y divided by 2 equals 10 divided by 2, these just cancel out. The whole point every time we do this is it will cancel out the number that's there and leave me with just y. 2y divided by 2 is y. 10 divided by 2 is 5. So I looked for what was done to y, and I did the opposite to both sides to get y equals 5. A divided by 3 is 4. I have to reverse what was done to A to find out what the original number was. The opposite of dividing by 3 is times by 3. We know that this will cancel out and we'll be left with A equals 4, and then I write times 3. A equals 12. Now, if you prefer to do the working like this, here I've got A divided by 3 equals 4. If you prefer to say it was divided by 3, I've got to do times 3 on both sides. Remember that cancels and you get A equals 4 times 3, A equals 12. It's okay to put these in, but in later years you'll have to stop using this as a support. So your one-step equations, you can tell they're one step because there's only one number hanging out on the side with the unknown. You work out what was done. X had 4 taken away. You do the opposite to both sides.